Okay, this is question number 10. Given that theta is measured in radians, prove from first principles that the derivative of sine theta is cosine theta. You may assume the formula for sine a plus minus b, and let as h tends to 0, sine of h over h is tends to 1, and cosine of h minus 1 over h tends to 0. Okay, well, proving from first principles, the first principle formula is in the formula booklet. So, f of theta is sine of theta. Shall we find f of theta plus h? No, we'll do it all in one. So we'll say that f prime of theta will be equal to the limit as h tends to 0 of sine theta plus h minus sine theta all over h. That's in the formula book. You do not have to remember that one, okay? But you will remember it from doing tons of questions as you go along in the course. So we've got the limit as h tends to 0. Make sure you carry your limit all the way through. Now, sine theta plus h, the formula for that is in the formula book, but you will remember it from doing tons of questions. So you get sine theta cosine of h. Put a bracket around your h as well, because it looks like cosh is a hyperbolic function. Plus cosine theta sine of h, not shine, it's in the one from the hyperbolic functions in further maths, minus sine theta, and we're all going to divide that by h. Looks pretty messy, shall we tidy that up? So we get the limit as h tends to 0 of. Now, let's do a bit of factoring, make it easier for ourselves. Sine theta cosine of h minus 1 in a big bracket plus cosine theta sine of h dividing all of that by h. I'm going to have to move on to another slide, so make sure you've got that before I move on. Okay, moving on. So we've still got a limit as h will tend to 0 of sine theta. Now we have to multiply that by cosine of h minus 1 over h, as we know that will tend to 0, plus, so break it into two limits, as h tends to 0, of cosine theta times sine of h over h. Now, that's pretty good because it enables us to basically finish this. Now, I'm going to bring the sine theta out of the limit because otherwise I'll be taking that into account as well. Plus cosine theta limit h tends to 0 of sine of h over h. Okay. So, finally, I need to evaluate this then. So, we know that this will tend to 0 and that will tend to 1, so we're going to use that to our advantage. So we got sine theta, well, that will times by 0, and I add cosine of theta multiplied by, well, that'll tend to 1, won't it, from the question. Okay, so sine theta times 0 will give us 0. Cosine theta times 1 will just give us cosine of theta. Okay, as required. End of proof. Okay, that's how we can get all 5 marks here for question number 10.